All right, everyone, welcome back. This is 9.2, transforming sine and cosine functions. And of course, we are going to be focusing on shifting it this time and actually graphing it. Now, your learning goal is to vertically and horizontally stretch the graph. And what I mean by that is we are going to be stretching it upwards. Obviously, we are going to be contracting it closer together. And we are going to be changing the period, which if I had a sine function like this, it would be shorter or longer. Okay. Now, this is kind of a review. We've seen this stuff before, okay? But I want to hit on two things before we get started. You do need to remember that your sine functions start at 0, go up to the amplitude, down, and back to the amplitude. Or excuse me, back to the midline, excuse me. Okay, so your amplitude is here and here. Your cosine starts at the amplitude, goes down and crosses back to the amplitude and back up. Okay, so your amplitude is up here and here. All right, now, in the last lesson, our Desmos exploration and this part focused on graphing these functions from scratch, and it was a pretty good Desmos exploration for this lesson because you only really focus on identifying information last lesson. So I'm going to clip in the Desmos exploration from last lesson. If you don't want to watch it again, you don't have to, but I think it'll be pretty good warm-up for these problems, okay? All right, so here we are on Desmos. I think this is going to be one of the more helpful Desmos explorations because I just gave you guys a ton of information really, really quickly, okay? So notice how we can see just how periodic a sine function is. Okay, now if you look at the x values, they are numbers, so it doesn't look like it's in radians, but if you think about it, 2 pi, well, 3.14 is what we use kind of to abbreviate for pi. 2 times 3.14 is 6.28. And if you look at where 6.28 is for an x, you know, that's right where this crosses for that first time. So it is still in radians, okay? Now, we have an a value of 1, we have a b value of 1. Watch what happens as I increase the b value. You see how the amplitude increases, okay? Right? And notice how its period hasn't changed. It's still going right through 6.28 where 2 pi is, okay? Now, if I go below 1, see how it kind of, you know, it shrinks, it compresses, right? And then if I go to negative, see how it's going down instead of up from 0. It's just the opposite, right? It just flipped. See that? Look. Okay. All right, getting carried away there. All right. Now let's bring this back to 1. Okay. And then I have my b value. Now, we haven't seen what b does yet. Exactly. So watch the period. See how it's shifting out? Okay. We're just changing the period. It's going to the same height, right? But we're changing, you know, its periodic cycle, okay? And this is that horizontal stretch, okay? Now, believe it or not, this is exactly how radiation works, right? Your cell phone is sending signals that follow wavelengths just like this, right? And they can tell by the frequency of it, by how many times, they can tell who's sending the message or what kind of message is being sent by how many frequencies they can count in certain periods, okay? Now, I hope this kind of helps you see, you know, if I could just, you know what, let me quickly just change this to cosine. Let's do that. See if this will show real quick. Yeah, it worked. Okay, it's got a lot of parentheses, but it worked. It's the same thing here for cosine, but notice how it just looks like the whole thing is shifted over a little bit, right? And, you know, we think of it as starting from 1, okay? All right, and you know, a value affects it same way, okay? So hopefully kind of helped seeing it this time. We're going to dive in and we're going to do 4 problems, okay? All right, hopefully that explanation was helpful. Now we are going to focus on graphing. We have 4 problems, and they're going to be spread between you and me. Now, the first thing you need to do, obviously, is identify that amplitude, right, which is right here. 3, it's a sine function, so we'll be starting at the center, going up to 3, down, back to 3, and back to your midline, okay? Now, there is no number here for period, for b, So it's just 2 pi divided by 1, or just 2 pi as our period. Now, this is where things get tricky with graphing. When you have a standard period like 2 pi, it becomes very easy to break this out into segments, okay? That are basically dividing that by 4. However, when we get to some of these other ones where we have b values that changes it, it gets a little bit difficult sometimes, and that's okay. We're going to figure those out. Now, my recommendation to you is to, I know this is 2 pi, so it's easy to split it up, but just take whatever your period is and divide it by 4, and that's going to help you really find out what your segments are supposed to be. Now, 2 divided by 4 gives you 1/2, or just pi over 2. So my segments are a distance of pi over 2. So I'm going to draw 4 segments. Let's do all the way out here, half of that. Boom. Okay. Now we have pi over 2, right? Because our segments should move by pi over 2, pi over 2, pi over 2, all the way to 2 pi. Now, I'm going to actually add them. But if you could do in your head pi over 2 plus pi over 2, then that's fine too. Okay. So to go from here to there, we have to add a pi over 2. So that's pi over 2 plus pi over 2, which gives you 2 pi over 2, or just pi. So we're here at pi. Now again, to go to the next one, we have to add a pi over 2. So pi over pi plus pi over 2. Now you do have to put this into the same denominator again, which we had that already right here. We just simplified it out. We add that together, we get 3 pi over 2. So that's what this is. Okay. And then finally we have 2 pi. Now we could have added it, but again, that's where our period ended, was 2 pi. Okay, so I'm going to erase all this. Now, do we have to really do it for this one? Not really, but you'll see that when our period is not 2 pi, and maybe it's like 3 pi over 2 is our whole period, it really helps to divide by 4 and then add that as we go. So we have 4 marks. And we need 4 marks because we start here, and at the first mark we should reach our amplitude. Then at the next mark we should cross, and at the next mark we should reach our amplitude and then come back. That happens at 4 places. Okay. Now to graph this, I'm going to put my amplitude onto the graph. So we have 1, 2, 3, -1, -2, -3. Okay. So we're going to start at 0. We're here. We're going to go up to our amplitude. We're going to cross back to our amplitude and make it all the way back. And that's it. We just graphed 3 sine of theta. Okay? And you're going to do it this way. Find your amplitude. Find your period. Divide your period into 4 even segments. Use those segments to create your x-axis. Draw your amplitude on the graph. And then draw your function. Okay? Now, let's do another one. Except for this one, it's a cosine function. Why don't you guys? Well, no, I'll graph this one. You'll have a time to do one in a minute. Okay. Now our amplitude here is still 2, but we do have a reflection because our a is technically -2. All right. Now this has been a tricky point for a lot of people here. A lot of students is like, why wouldn't I just say the amplitude is -2? Because it still just goes up to 2 and at -2. It's just an amplitude of 2. That is what it is stretched by. The negative is about the reflection. Okay. So you are looking to say that the amplitude is just 2. All right. And if you think about it, this isn't really asking you what a equals, right? It's asking what the amplitude is. And those are kind of separate things. All right. And if you're confused by this, don't worry too much. I'm not going to ask a quiz question like that. All right. Now, your period, again, we have a b value of 1. So 2 pi divided by 1 is just 2 pi. And now I'm not going to divide this by 4. We know what that is, right? We've seen this. It goes by pi over half. So I'm just going to go right into splitting my graph. So we have 2 pi. Half of that is pi. Half of that is pi over 2. And in between is 3 pi over 2. Okay? Our amplitude is 2, so this goes only up to 2. I am marking a 3 still, though. Now, the thing about cosine, if you have to remember, is cosine starts at the amplitude, right? And because it's negative, though, it flips. So instead of starting at the positive amplitude, we're going to start at the negative amplitude and do it the opposite way. And just kind of a quick, tidbit here. If this was a -3, instead of starting at 0 and going up, we would have started at 0 and gone down like this. Okay? So here, we're starting at our negative amplitude, -3. And we're going to cross at the first segment, reach our amplitude, cross at the next segment, reach our amplitude. Okay? So you can see that at each mark. Amplitude, cross, amplitude, cross, amplitude. Okay? That's how it always is. Now, that's it for this one. Not too bad, right? Okay, I'm going to do this one. I'll give you the last one. All right? Now, we have 4 sine of 2x. Okay, so our amplitude is 4. And now this time we do have a b value of 2. So it's 2 pi divided by 2, or just pi as our period. Okay, now what this is going to do is it's going to make our graph look smaller. So here we went all the way out to 2 pi. Now we're only going all the way out to pi for a single period. Okay, so I'm going to still draw all the way out to 2 pi for this one so that we could see that it's shorter. Okay, now I'm going to take pi, I'm going to divide it by 4. That helps me get my segment, so I should move by pi over 4. So I need to go like this, this, and this. So I have pi over 4 as my first move, and then again, to go to the next one, pi over 4 plus pi over 4 is 2 over 4 pi, or just 1 over 2 pi, or pi over 2. Okay, now that's pi over 2 or 2 pi over 4. Okay, obviously we need the most simple one, but if I have to add another pi or pi over 4, I could just use this one really quickly, right? So I could say 2 pi over 4 plus pi over 4 again is equal to 3 pi over 4. So that's this one, 3 pi over 4. Okay, and I'm going to erase all that work. Now, I'm not going to keep labeling over here because we only want to graph over a single period. Okay, this is just here for reference to show that it's now going to be much shorter. Now, this is a sine function, so it starts here at 0. It's a positive value here, so it is going to go up first and not down. So let's draw out our amplitudes, or our y-axis really. Okay. And let's use a highlighter here. So we start at 0, and at the first mark here, we should be reaching our amplitude, crossing, reaching our amplitude, coming back. Okay, so we put all those points. All right. And now, of course, this would continue. It's a sine function. It goes on forever, right? But that's it for this one. And compare it to this one, right? It went higher. It went all the way up to 4 as opposed to just 3. And it ended here. If I were to draw those on the same, it would look, it would look like this. If I drew them on the same, or close to that, okay? So it goes higher, and it is shorter, okay? It has that phase shift or not the phase shift, sorry, that's another lesson. It is, it is horizontally shifted, okay? Not this one, this one, okay. All right, you guys, here is one for you to do, okay? Why don't you go ahead and give it a try, and then we will bring it back together. So pause it, give it a try. Okay, so hopefully you got this one. You identified that you had an amplitude of 2. Now you may have gotten here and gone like, what on earth is my b value, right? Well, if you look at it this way, you have 1 over 2, okay? I know that there's this b, well, it's called beta, right? But that's your input, all right? So there's technically 1 in front of it. So it is 1 over 2, all right? Just like that. So the formula for our period, it's 2 pi over b. Well, here, that makes it 2 pi divided by 1/2, because 1/2 is our b value. So you need to keep change flip, and what you get is 4 pi. And so this is now stretching. It is horizontally stretched, okay? All right, now, let's keep going here, okay? That means that, I'm gonna try and keep my my value is the same. All right. Sorry, I'm losing my train of thought. Here we go. Okay. Let's take 4 pi divided by 4. That gives us a single pi to shift by. So if you remember, we were drawing 2 pi all the way out here. I'm still going to draw it all the way out there so that we can kind of see how it stretches. Let me erase this. We're going to need a little bit more of a pathway here. And this goes all the way out there. Okay? So then we have about 3 pi and 4 pi. Because again, our period is 4 pi, so it needs to be broken into 4 segments. Okay? Our amplitude is 2, so this goes up to 2 and down to -2. It is a cosine function, so it starts at your amplitude. And since it's positive, it starts up here. Okay, so I'm going to draw this. So we're starting here at the first one I cross. I reach my amplitude, I cross, I reach my amplitude. So you can see how it's horizontally stretched, okay? Because it's, we pushed it out kind of both directions here, all right? We had one function that only existed in between this distance. We had another function that only existed in between this distance, right? And that period. And then now we're all the way out here for a single period, okay? So to kind of recap this, your amplitude, this is your vertical shift, or vertical stretch, I'm sorry, or compression if the value is in between 0 and 1, okay? Your period is your horizontal stretch. So let's clarify that, okay? All right. So that's all I got for you guys. I hope this one was, you were able to understand it, and I will see you guys next time.